I got a question for you. Why 41? What is it? Have you guys seen it? 41 what? Yeah, I don't know. I've been farming ore all morning. I'm tired. All right, here we go. Looking at stuff. We have the explicit formula that's going to give us the nth term of some sequence. We are going to derive this together. So I think we've done a derivation already. It's just saying, instead of me giving you a rule and saying use it, we're going to see how does this rule arise? Where does it come from? So that it's not just you blindly trusting my guidance. Okay, we're going to derive the formula. And what's weird about this is there's never going to be like explicit numbers written. I'm never going to say it's 1 and 3 and 5 like we did yesterday. We're going to do it all in general. So if you give me some sequence, a sub n, if we check our notes yesterday, what's the first term? How do we write it? A something. A sub 1, right? Okay, this one's going to feel super silly, but do you guys agree, and I'll go back to the black color, do you guys agree with the following statement? A sub 1 is equal to A sub 1. Like, it seems almost not really worth it to write, but it's true. This is the reflexive property. Those of you from geometry, you may remember it. I'm sure you used it when writing proofs and such. Here it is. Okay, here's my challenge. I want to get A sub 2 as well. Now, if you need a second to chat with your neighbors or look back through your notes, I'm good with it. If I have an arithmetic sequence from one term to the next, what do I do? Like, how do I find the next term? Ooh, I heard somebody say, and Kennedy, you said use the what? So maybe, but like if I had, so again, I'll just put this one up here. I don't know if it's the same one. I think it is. If we had this one, how do you know, everybody know the next term? How did you know that? You've added 3. There's a pattern, right? You have identified, it has a very specific name. Check your notes from yesterday. You've given me something. The common difference. So to move from one term to the next, you always just add something, right? Now it might be subtract, but that's just adding a negative. So just bear with me. Do you agree that if I wanted to get A sub 2, I simply need to take that previous term, A sub 1, and add the common difference D? Like in this one, if A sub 1 was 2 and my common difference was 3, the next term would be 2 plus 3 is 5, and then 5 plus 3 is 8, and we can generate it this way. Everybody still on board? Okay, nothing crazy happening. I do think that it's useful to make one little note. I'm going to underline just this part, and I'm going to note this is previous term. Previous term. And I'm going to underline just this part, just the A sub 1. Now, we're going to add more to this. The common difference D. So we'll go ahead and say previous term here, and I'll make sure that it's really clear. And this guy from yesterday, one more time, what is this? The common difference, the thing that we're adding or subtracting. And then since we're labeling stuff, we may as well, what's A sub 1? It's the first term, and A sub 2 is the second term. Okay, before we do the third one, questions? Cool. All right, we're going to do the third one together, and then I'm going to have you guys do a couple and see if we can't find a rule for this. And we'll write them all nicely. We're going to have a bit of scratch work here. What if I wanted the third term? Let me get somebody. I'm going to give you 10 seconds. Chat quietly with your neighbors. I'm going to call on one random person. 10 seconds. Five, 4, 3, 2, 1. Number Angel, how do I get the third term here? Everybody agree with A sub 2 plus D? Okay. Is there another way we could write this? Now, mine are going to be ugly for a second, but the reason that I went through writing the previous term, I always just take the previous term and I add D to it, right? From here, did we write down a second ago what A sub 2 was?
It was 2, right?
It wasn't 2. What does it say on our screen? A sub 2 is equal to what? A sub 1 plus D, right? So what we've written is completely true. I'm going to do some circling. I wouldn't do it in your notes because it's going to make it ugly. This right here is A sub 2, right? Which means if we wanted to clean this up a little bit, I think we could write this instead of a sub 2. What can we write? So just in a2 right here, I'm going to replace it with a sub 1 plus d. And again, that's just a2. What do we still add on the end of it? D, right? Can we clean this up? A sub 1 plus d2? 2d is much more common. So we're not going to use d sub 2 because that would indicate that we're talking about two different things that we're going to add, and we have to add the same thing. There's just two of them in this case. Okay, I'm going to write this, and we'll clean it up and make it nice here shortly. I want you to do a sub 4, a sub 5, and then here's the challenging part that we'll come back together, I assume, to figure out all of it. I want you to do a sub n as well. You should do some scratch work on the side over here because we're going to get this in every problem. But I'm going to give you guys a couple minutes. I want you to write a sub 4 and a sub 5 with an a sub 1 in it like we did right here. Cool. I'll give you guys a couple minutes. I'll walk around to help anybody who might need it. Do I need like completely silence in here? No, I kind of hate awkward silence, honestly. So chat it up. I'll give you guys a couple minutes. This is going seemingly okay for a few groups, but if you're struggling with it, that's okay, right? Welcome to math. If I want to do a sub 4, all I need is if there's confusion, because I saw most people doing this, is this correct? It's a sub 3 plus d. So it's correct, but it's not what I asked you for, right? What can I replace a sub 3 with? So a sub 3 was a sub 1 plus 2d, right? So let's do that. A sub 1 plus 2d. That was just the a sub 3. And then we add d to it again. Because check it out. When we do this, if I'm losing you, the color coding is going to help. A sub 3 plus one common difference gets me to a sub 4, right? And we just plug this in for a sub 3. So here's a sub 3 still, plus one common difference. We just wrote it a little bit differently. Why would I write it like this? Why would I take the time to do this, do you think? Maybe. I hope that's not the case, but we'll find out. Gosh, there is a pattern here. A sub 1 plus 3d. What's the fifth term? Oh, it's a sub 1 plus 4d when we do the same thing. Kennedy, if that's about math, awesome. If not, you're talking very loudly. Cool. When we're here, what's the pattern? Okay, so if you wanted to generalize this, it's weird to try to generalize, right? For the nth term, am I still going to have a sub 1 in it? Plus, here's that big part. How do I decide this number? Say that again? It's one less than what? Than what I'm finding. So what's one less than n? Not letter-wise. It's n minus 1, isn't it? Everybody agree with this? And you say, do you really not? What's 1 less than 7? What's 1 less than 7? How did you do that? Oh, you subtracted 1? So check it, keep that idea. What's 1 less than n? You're not going to be wrong. Yeah, 100%. It's n minus 1. Okay, when we do this, we get this lovely formula right here. Now, in your notes, if like you probably have some scratch work off on the side, that's fine. This right here, I'm going to put a big star next to it. And you want to see differences. Do we all write English, you think? I think we can all write English. I'm pretty sure of it. We're going to define this. We're going to make sure it stands out in our notes. And then I'm going to make you guys do something weird for me real quick. Okay, this right here is the explicit formula. This is it. This is what we use to find the nth term of any sequence that's arithmetic. Yes, sir?
So, like, why do we have to do, like, A1 plus 3D?
So let's dig in and see what this is really telling us. Okay, so from here, we have a way to get the nth term without having to write all of them out. And let's just see why we took the time to do it here. I promise it wasn't to confuse you. This was to get more efficient with things. So we'll do an example. Sonny, give me a number.
12.
Okay, so for the following, we're going to find the, I don't know, nth term. And we're going to look at this, and we'll do a couple different ones. And we'll say of, and we'll write a sequence. A sub n equals, or we'll do it here. Sonny said 12. RJ, give me a number. Not 6, 7. 28. Okay, if I'm going to build an arithmetic sequence from this, what do we have to add to get the next term? So we add 16, I get 44. I add 16 and I get 60, and this list goes forever and ever, right? Okay, is this arithmetic? How would you check to verify? Good. We would check the common differences. We have built this with 16 as a common difference. It's going to work. So here's what I want us to do. Right now, if I said, give me the 5th term, could you do it pretty easily? Yeah, you would just be 76, right? You just add. What if I said, let's find the 30th term? Could we build this list out all the way? Yeah, it would take, I don't know, a couple of minutes, probably like 5 minutes-ish. But it's only at 30. Is that a big number? Give me a bigger number. 31 is a natural answer. 67. Yeah, let's check it out. If we look at this, I don't want to write out the list, so let's try to use this formula instead. Do you guys know, and I still have this on the board, do you know the first term? 12. So check it out. We're just going to plug directly into our formula. A sub 30, which is which term? You're not wrong, but n is 30. We would say this is the which term? Okay. The 30th. The subscript is just whatever number we're at, right? So check it out. What's the first term again of this whole sequence? 12 plus, what do we just pick for n?
30.
So what's 30, and I'll do it all out here, 30 minus 1 inside the parentheses. And what do we identify the common difference as? Okay. Boom. Check it out. We're going to do a little mental math here. This is 12 plus 29 times 16? Okay, me neither. That's okay. Hey.
Wait, actually.
Could you, does everybody in here know how to multiply?
464.
That is correct.
Actually?
Yeah.
Oh, yeah. Wait, what?
Cool. Nice job. You're better at mental math than I am. Okay, we just got 464. Was that faster than writing out the next 25 terms? 100% it is. If we had done this any other way, like if I had tried to do this with A2 and A3, we would have had to work all the way out. So that if I wanted this one, I would have to use something different. Now, Eli noticed something similar. When we derived this formula, you used A1 just because I told you to, right?
Yeah.
Could we use A2 instead?
Yeah.
Yeah. We could use any term, but A sub 1 is usually the best because it's given right away at the beginning. Cool. I want you guys to do one more for me. Same sequence or different sequence? Different. Okay, so let's say on B, and the example is going to be weird. Let's say it's 6, -2, -10, -18, so forth and so on. I want you guys to find for me A sub, I don't know, 15. Cool. I will give you guys a couple minutes. It won't really take a couple minutes. You're always welcome to grab a calculator if you want it. You can also do longhand multiplication, your call. Find me the 15th term without just building up your list. For this, only thing that we need to successfully complete this problem, I guess 2 things. We need to know this formula, which we have on the board, so that's pretty awesome. We need the first term. We have it. And I need the common difference, which I didn't write anywhere, but I think we can determine. Somebody claims D is -8. Do you guys agree with that? Okay, so I'm going to keep that off on the side. Do we know the first term?
Yeah.
What is it? 6. Okay, so it's 6 plus, inside of these parentheses goes n minus 1. I didn't tell you explicitly, I didn't say here's what n is. Can you tell me what n is?
15.
It's 15. I'm going to write it here. I don't know that I really need to. 15 minus 1. And then I'm going to write something that I saw somebody mistakenly wrote. They had calculated everything right, but I want you to tell me what is wrong here. The parentheses. This thing tells me to do this and subtract 8, right? Now, if you have this on your page and you did the right operation, kudos. Get used to showing exactly what you're trying to calculate, because it'll help us find errors if we have them. So let's check this out. This is 6 plus 14 times negative 8. So 8 times 10 is 80, and 32 is negative 112, right? Okay, so 6 plus negative 112. Can I just call it plus a negative? That's kind of redundant. Minus 112? What did we just find that the 15th term of the sequence is? Are you sure? Negative 106. Boom. Look at that. I did not denote this the same way here. I probably should have. We got to the answer, a sub 30. That looks like a 9. On our first one, a sub 30 was 464. We have a way to calculate these things out. What's up? I put dots to indicate my answers. Yep, good question. I don't know. I trusted somebody's math. 12 times 12 plus. Ooh, Angel noticed something. The multiplication, I was psyched that he got it, and I was super excited. What do you think I might have forgotten to add? Let's add 12 to it. I didn't double check you. I was psyched about your multiplication. If you add 12 to 464 from part A, what do we get? Oh, okay. 476. Your math was right. My math was wrong. Yeah. All right. We're going to take like a 30-second brain break for you, or like a minute probably. You guys all learned to write different places. You might have had some of the same teachers. Here's what I want to see real quick. We're going to see this really weird. Do we want or need another example of doing this? Okay. So here's the deal. This works. What type of sequences have we been talking about the last couple days? Arithmetic. This works for arithmetic sequences, which means if I give you a sequence and ask you for some term, if you're going to use this formula, you need to check that it is in fact an arithmetic sequence. Don't just think a sequence is. Now, for arithmetic sequences and every other sequence, there's another way that we can write these things down. So we looked just now at the explicit definition. We're going to blast through this next one, and I want to stay consistent with how I'm labeling stuff. So that was a dash. We'll use a dash. Explicit formulas are cool, and they work really well, especially for arithmetic. It turns out that if you look really closely and analyze it, you're just giving me mx plus b. You don't even realize it, but we're just doing a linear function. That's it. Okay. As opposed to that, we have a definition that is called recursive. So we have an explicit definition or rule, and we have a recursive rule. How many of you have seen or know the word recursive? Okay, so when I think of something being defined recursively, I think of it as just repeating and repeating and repeating, which we know that arithmetic sequences do this because they just add the common difference over and over. When we look at this, recursive rules simply give the nth term. And just to really lock this in, how do we write the nth term of a sequence? Like a sub 1 is the first. So careful. Could we just see the nth term as just a sub n? Give the nth term a sub n using the previous term. Love it. Okay, now for this, I'm going to say terms, but I'm going to put the s in parentheses because sometimes we do this. Now, in this example, if you didn't hear Sebastian just now, if I'm trying to find the nth term, what's 1 before that? A sub n minus 1. Okay, now what's weird about this is we can shift where we're starting, and we're just going to see quick example. If, in general, for the nth term, what we mean by the recursive definition for an arithmetic sequence, super easy to do. It is simply, I'm going to make an asterisk so that it doesn't look like a minus sign. If I want to find a sub n, and we already used this idea without writing it down, I simply take the previous term, a sub n minus 1, and I add what to it for an arithmetic sequence? The common difference, d. This is it. Now, you guys have been doing this without ever seeing the word recursive or recursion. This is exactly what we've been doing though, right? So if I tell you an arithmetic sequence, so we'll do a quick example, and a sequence, and I'm not even going to tell you the first one, is written as, and then we're going to format this just to make sure it's clear. we're going to make n and a sub n table so we can see what the number is. Now, let's just hypothetically say we didn't start at 1. For some reason, we picked up a page and it was like a whole book of a sequence, and we just looked at one page in it and saw the middle of it. Okay, let's say we started at n equals 12, and we had 12 and 13 and 14 given. So I don't know the first term. I don't know the second, third, fourth, fifth, any of them. But let's say that at 12, we get something like, I don't know, we'll go 1.5. And then the 13th term we found was 1.0. And the 14th term, let's just say, was what? 0.5. Love it. Okay, just from this, if I gave you only these 3 terms, not including a sub 1, could we write the explicit formula right now? Can we find the common difference? What is the common difference? Negative 0.5. Okay, good. What's the first term? I don't think so. That's the 12th term. What's the first term? Why do you think it's 12? So we're given the 12th, the 13th, and the 14th terms, right? I'm going to give you a huge, I'm just going to answer it. You don't know it, do you? Could you work backward 11 more steps to find it? Do you want to? No. So if I wanted something like, I don't know, a sub 15, for example. If I want to find a sub 15, using our recursive rule, super easy, bless you. All we have to do is take the 13th or 14th term, a sub 14, and we're going to add what to it? What is our common difference? Negative 0.5. On the next line, do you think we're going to write plus a negative? I could use parentheses. There's a better way to add a negative. Yeah, let's just subtract. I agree with you. Okay, do we know these things? I don't know why I said that instead of D, but what's a sub 14? 0.5 minus, the common difference is 0.5. What's the 15th term? 0. 0.5 minus 0.5, and we have it. Again, my bullet point is just indicating my answer. For arithmetic stuff, legitimately, not my favorite thing to do, just so you know. Recursive definitions work better for uglier types of sequences. We saw a sequence yesterday at the end of class that was all wonky, didn't we? Nope, that was geometry. We're going to look at a famous sequence. Did we talk about Fibonacci yesterday? Yeah. Anybody remember what it was?
1 plus 1, 2.
So check it out. We're going to do another example where I'm going to ask you to expand this sequence. You guys see what I did there? Gosh, efficiency, right? Cool. All right. I'm going to give us a rule and a couple of terms. So here we go. We're going to say that for A, this first one, if I want the nth term, all I'm going to do is I'm going to take a sub n minus 2 plus a sub n minus 1. Now, knowing that these are all linked together, we'll see it as we practice, with, let's get a couple things given. Let's say a sub 1 is equal to, I don't know, we'll say 5. And a sub 2 is equal to, I don't know, 13. I want us to write the first 5 terms of the sequence. Now, it can be challenging to work out. Do you want to try it together as a class, or do you want to try it at your tables for a moment before we jump in?
Wait, that's 5 plus 1.
A sub 1 is 5, comma, sorry. A sub 2 is 13. Let's start it together, and you'll see this is way easier than you think it is. So, right off the bat, we need the first 5 terms, and we'll even write first 5. Right? First 5. Now, for this, I'm going to be, just so you're aware, not arithmetic. We are not adding the same thing every time. I know the first term is what? Okay, so we got that one. Good. A sub 1 equals 5. What's the second term? 4. And then we need to find a sub 3, a sub, wait, it's not 4. Why did I trust you? What is the second term? 13. Okay. Where'd 4 come from? Okay. Do you see why it's not 4? I don't know who said it. Okay. 13. Okay. I appreciate that you're answering, but don't just shout out random stuff. Cool. Well, gosh, if I tried to assign this rule, and I'm going to do some scratch work over here, we'll do it in purple, and I'll just make sure that we have it nice and clean. If I want the third term, and I use this rule, if according to this, if I want some number, that term, this is how many behind it? So like if this is the third term, for example, what would this be? If n is 3, which it is right here, right?
Yeah.
What is a sub n minus 2?
A sub n minus 2 plus 1.
A sub 1 plus what's a sub n minus 1?
A sub 0.
Not quite. What's the n value here?
A sub n minus.
So we're going to make sure we all get this. In this particular problem, what's the n that I'm solving? 3. So when I do a sub n minus 2, and I'll expand this out. You don't have to write all of it. But do you agree that this could really be written as a sub 3 minus 1 if we use that same rule? Plus, if we do it all out, the next one is still 3, but now it's minus, that should be 2, yeah? Sorry. 3 minus what? N minus 2 shows up right here. This has to be 3 minus 1. Okay, we'll clean it up a little bit more. What is 3 minus 2? So I can make this subscript nice. So a sub 3 is allegedly going to be a sub 1 plus a sub 2. Do we know those two terms? What's a sub 1? What's a sub 2? Can you guys add those up? Hey, it's 18. Now, the scratch work, you might need it moving forward. You might be able to just look up here and make sense of what's happening. But I'm going to give you guys like 60 seconds, and I'll flip the timer. I want to see what you come up with. If you're struggling, do you just sit there for the next 60 seconds?
Yeah.
I mean, you're going to sit there probably, but don't just sit there and wait for the answer. Ask your neighbors, ask me. Cool. 1 minute, go. Cool. All right, so checking this out. Quick curiosity, how many of you guys use Scratchwork to work these out? Totally cool. Okay, we're going to do one more with Scratchwork just to verify, and then we'll do the next one, and I think we can see it without the Scratchwork, I imagine. Okay. Let's look at it. If we're looking for a sub 4, this rule says take, what's 2 before this? 2 before a sub 4 would be a sub 2 plus, what's 1 before this?
Oh, 3. What's 3?
1 before 4 is what this I'm referring to because we're dealing with the fourth term. What's 1 before that?
3.
Because this rule says for any number, just take the 2 before term plus the 1 before term. So check it out. What's A2?
Is another one?
13 plus what's A3? And those add up to 31. Now, we can do the scratch work. I'm fine with that. But if we look at this and we realize that this is the sum of the previous two terms. These are the two terms before whatever we're after. If I just cover up these other ones, are these the two terms before a sub 5?
Yeah.
Can you add those? What's 18 plus 31? 49. And I didn't ask you to do this, but could you give me the sixth term? What are the two terms we're going to add up? So that's 80. And all of a sudden, we have this sequence that we can start generating. Can I use the formula that we worked out like 10 minutes ago to do this one? Why not?
Because that one was like constantly going up and down. You can't find it after.
The difference isn't common. I add 8 from here to here. I add 5. I add 13. Like it changes, right? It is not common between them all. Recursive definitions for arithmetic stuff, honestly, not a huge fan personally. However, there are sequences and a lot of sequences out there that are not arithmetic where we need better ways to look at them. Fibonacci, typically defined like this. This is the Holonacci, is what I would call it, because I use the same rule that the Fibonacci sequence used, but I'm not Fibonacci, I'm Holloway. Okay. Thoughts, feelings, how you're doing with the sequence stuff? Feels okay? All right. Anybody here ever heard of Carl Gauss? So there's a whole field of mathematics that you wouldn't see until you were like almost done with your college degree if you're studying math, called Gauss theory. Carl Gauss, G-A-U-S-S. Gauss was a super prolific mathematician in the 1700s, and he was kind of annoying to his teachers, like really, because this kid was insanely bright. So we're going to try something real quick. I'm going to show you what Anybody in here 12 or younger? I don't believe you. All right, obviously not, right? We're in a high school class. Okay, so here's a problem that Carl Gauss got when he was 12 years old. He was annoying his teacher in class one day, and no calculators existed. He was 12, and he's bugging his teacher. And the teacher said, you know what, Carl, I don't know if she actually called him Carl or not, but I want you to do the following. I want you to consider this list of numbers. Can you guys tell me the next numbers? Okay, 7, 8, 9. It keeps going, right? So the teacher said, all right, Carl, you don't have a calculator. You're bugging me. I want you to add these up. I want you guys, we'll jot this down. We'll get it nice here in a second. I want you to add up the first 100 numbers for me. And I'm going to give you, I don't know, how long do you think it took Carl?
Wait, 1 plus 1 plus
1 plus 2 plus 3 plus 4 plus 5. You can't use a calculator. Like, if I gave this to a 12-year-old, what? Like, I would do this to say, stay busy, like, don't bug me, right? Okay. I want you guys to start. By the time the last grain of sand falls, Carl was done.
1 plus 1 plus 2.
Nope. 1 plus 2 plus 3 plus 4 plus 5, all the way up to plus 100. I want to know what is the sum of the first 100 numbers. You can't touch your calculators. Okay, Carl did this in 60 seconds. Let's see if you can. He was 12. 60 seconds.
I know the answer.
Do you?
Yeah.
There's no high probability.
I would think that.
I'll tell you, that's a terrible guess.
I know there's a phone down there.
There's a what?
There's a phone down there. See?
Where?
On your book or whatever.
There's a phone on my book.
Or your like sheet.
I didn't say I was going to do it. I just wanted you guys to do it. You're bugging me. Liam,
I got a number.
tell me your number.
5,050.
5,050. How did he do it? You're right. Don't tell anybody how you did it. Cool. So here's what we're going to do. We are almost out of time. We have a little bit more on this lesson. Okay. Who does not have a textbook in here? Okay. So people who are traveling. Cool. Sweet. Okay. Those of you that are traveling, I've already given you access to the online one. I couldn't do it for everybody yet, but we're almost there. We're going to do a short assignment in your text this evening. Okay. If you want to check your answers, where are they? Google Classroom. And I'll show you exactly where. I want you guys, we're going to knock out homework 1.4.1. And I'll go to the classroom. I'll just write it there so I don't forget. Okay. You guys this evening get homework 1.4.1. So it's 9, 4. What did we do yesterday? I don't know why I didn't post anything here. I definitely uploaded the video. Okay, we'll get all that worked out. Your homework is 1.4.1, meaning that I'm going to have a second part of this assignment. It's the only reason I would do it like that. You will find this waiting for you on page 37. If you want to take a picture of your work, no, you're traveling, right? Yep, you can email it. That's fine. Okay, I want you guys to do, I don't have a Snapchat. Not that you know anyway. Cool. I'm really big on TikTok and RedNote. Cool. All right. You guys are going to do 1 through 3. And I know that there's some evens in there. And you're also going to do 5 through 11. You know, we could probably just say 1 through 11 in hindsight and skip number 4. Cool. Travelers, I want you guys to send me a picture of it. Those of you traveling, when you grab your phones here in a second, behind you on the board, you will see the directions for how you can access the books on the internet. No. You can take it if you want. If you don't want to take a physical textbook because they're heavy, take a picture of that. You can view the book on your phone. Cool. 1.4.1, page 37. Travelers. Where are you going? Where? Palmer. You'll have data? Cool. What do you mean? 1 to 11, skip 4. Okay. Oh, other travelers, before you go. I don't forget stuff. Ask me, John, when you do that. You guys work together. Open note, open book. Not open AI. Open note, open book. You can work with each other, not AI.
Okay.
Cool.
But what if AI is my partner? What if
No.
they all
Nope, AI can't be your partner. Sebastian, in all reality, I'm okay with the use of AI to help learn. If you have to use AI and you can come back and explain to me everything that you've done and you've mastered it, like, I'm okay if you use AI to help. Later, Raiders!